I built a special Tesla coil which gives large amounts of wireless energy continuously based on 4 MOSFETs in parallel, which remain cool in a large primary and secondary coil. Now let's watch a test light from this coil sizzle with wireless energy at just 20 to 30 volts DC input. You hear it sizzling? That's pretty cool, isn't it? We'll see what we can do with it. Let us show briefly now how this clever device works. It has both a power circuit and a control circuit. Now its power circuit, which I'm going to show you here and will be described more in slides below, comes off this 0 to 60 volt DC power supply, goes through this 10-turn soft copper primary coil which can be tapped anywhere, and down through these 2 1-ohm resistors and a fast diode into 4 MOSFETs arranged in parallel. He uses a 10-turn primary coil wrapped around a 2 times 500 turn secondary coil and is linked to 4 MOSFETs in parallel downstream on a big aluminum heat sink. The test light's just sizzling. Now we have explained the power circuit, and we can talk about the control circuit. Now this control circuit uses a MOSFET driver which is switched on or off by a resonance feedback wire from the base of the secondary coil. Here's the MOSFET driver over here, and here's the wire coming out of the base of the coil there. So let's see how that works. This one works off this DC power supply at 12 volts, goes through a little stabilizing capacitor, through a 1K resistor. Power comes into the MOSFET driver here and out to black. And there's a common ground between that black and the power supply black. Now, where's the signal coming in? What happens is the base of this big secondary coil is the resonance feedback wire. There are 2 wires because they're 2 strands, 500 each. It's bifilar parallel. In is wired to in and out is wired to out. That comes over here through this 150 turns of 1.25 millimeter wire, which is a choke, which adjusts the frequency of the signal slightly. It takes it down from about 580 to 530 kilohertz to make the MOSFETs work better. And that goes straight into the MOSFET driver. So you get the signal coming in here, and the signal coming out here, and it runs right here into these white wires, which are essentially a series of 10 ohm resistors that go into the gates of these 4 MOSFETs on a big aluminium heat sink. This new device can not only make a test light sizzle, but it can also make wireless energies which ionize gases such as helium or argon. And I have a helium cylinder here. We're going to put some gas through this little tube next to the test light and see what happens. We need about 30 volts and 25 watts to see this effect clearly. And you can see there's a slight blue glow here. When I put some gas in, watch what happens. So the helium is being ionized very efficiently. And there's a light nearby which will come on if you want it. So that's another practical use for this device. That's the theory and practice of this device. We're using 4 MOSFETs here to get much more power than from 1 MOSFET. You can go to 6 MOSFETs if you want. That's why we have these extra wires, but 4 is enough. And these are special MOSFETs. They only cost about $3 or $4 each, and they work at 530 kilohertz. And some others cost $25 each. So this brand is a special and a really good value. This MOSFET driver only cost about $5. So all the semiconductors are very, very cheap. And you can't do this with transistors. I've tried. You can't do this with a 0-volt switching circuit. This is the best way to do it. We get huge amounts of wireless power here without breaking any semiconductors, and we can use it for practical purposes. Thank you very much. Let's continue. The test light's just sizzling. And I have a helium cylinder here. We're going to put some gas through this little tube next to the test light and see what happens. We need about 30 volts and 25 watts to see this effect clearly. And you can see there's a slight blue glow here. When I put some gas in, watch what happens. So the helium is being ionized very efficiently. And there's a light nearby which will come on if you want it.